Alright, we are in AP Calc. We're looking at Chapter 4 here mainly, but sprinkled in also in Unit 1. We also have Chapters 1 through kind of 4 to 5. It's kind of all intermingled here, but main focus is Chapter 4 here. And this is kind of an overview of Unit 1 as well. And what we're going to be doing now is we're going to explore the ideas of categorical data with two-way tables. We will be discussing marginal frequencies and distributions as well. We will also be discussing not just the marginal frequencies and distributions, but we'll be discussing the conditional frequencies and distributions as well. All right, so again, as a recap here, if I'm moving too fast, you got to pause the video and write it down. That's why I try to have the words and the notes all over the PowerPoint so you can see them as we go. But anyway, here's a two types of data, right? We went over this in the last section. We have qualitative and we have quantitative, all right? We have two different types of data, right? And qualitative, or quality of something, is like the hair color. And I think you remember that example that I gave you before. We had a frequency table with hair colors on it, and that would have been a qualitative, right, table. Whether you are Democrat or Republican, right, that's a quality that you might possess, right, Democrat or Republican. Ethnicity, right, religion, those are qualities that you might have, qualitative, right. Race and gender is another example of a quality about you, making it qualitative. Qualitative is something that you cannot put a number on, okay? So can't put a number on Democrat or Republican. You can find the number of Democrats and Republicans, but those are your frequencies. Those are the counts that come from it, okay? So some stat books also, again, call this type categorical or categories, all right? So qualitative and categorical basically mean the same thing, all right? Then we have quantitative, right? Quantitative is dealing with quantities or numbers, right? Quantities are numbers. But the big question is, can numbers also be qualitative? All right. Can you think of an example of numbers being qualitative? Numbers. All right. Can you think of an example of numbers being qualitative? How about a zip code or area code? Those are numbers. All right. And the reason why it's a quality is it's a location of where you are. The numbers don't tell you some type of quantity. That's not what the numbers do. The numbers are telling you an area, right? Serial number, all right? That's just like a name of something, but it's a name given in numbers, so it is a quality of something, all right? The real question is, can you take those types of numbers and add them together for anything? That's how you can definitively tell if it is qualitative versus quantitative, and the answer is no. I can't take a zip code, add up all the numbers, and it be something substantial, right? You cannot take one area code and another area code and add them up to get some kind of super duper area code. So it is not a quantity, it's not a quantitative variable that we're talking about. And therefore, just because the number doesn't necessarily mean data, it doesn't make it necessarily quantitative. And this is one of those trick questions that they give you for an AP exam. Zip codes and area codes are examples of numbers that are categorical still. It's still a category. And for those that do not know, the smaller the zip code, right? So fun fact for you, the more west you are in the U.S. Just how it works. So for those of you that did not know that, that's how area codes work. The more west you are. Zip codes get larger, all right, as you go east. Therefore, all right, a better meaning of qualitative data or categorical data would be data where mathematical operations are meaningless. All right, qualitative data. When you try to do a mathematical operation on it, it's pointless. I can't add Democrat and Republican. I can't add blonde and brown. I can't add zip codes together. Okay? Quantitative means the data are numerical and mathematical operations do work. So quantities, you can normally add or subtract them together. So for example, quantitative data are height and weight, right? I can take two heights and two weights and add them together to get larger weights and larger heights. Age, you can add age together, all right? You can add wage together, miles per hour and income, right? You can add these things up. Temperature and time, all right? Again, quantities. And again, math operations are meaningful on these. You can subtract the difference of age. You can find the difference in wage, right? You can find the difference in height. Those are all meaningful. So there are two types of quantitative data, and I keep emphasizing these words for quantities or qualities because, again, they're so similar in verbiage as well. So I don't want people to get confused. But a quantitative data set, an example of that might be discrete data. And discrete is countable. All right, discrete is countable and finite, meaning there's a specific number of them. If you work on a farm with chickens, do they pop out 3.2 eggs, right? The answer is no, of course not. That doesn't happen, all right? Making it discrete. They do not pop out fractions of eggs, they pop out whole eggs. It's countable, all right? It's finite. If you roll a die, how many sides does it have? It has 6, right? Can you roll one die and get a 7? No, not one die. These examples only have something, the examples only have something in them that is countable and finite. All right, countable, finite. We're not talking about fractions. We're not talking about decimals here. They don't go on forever. It's countable. It's finite, right? There are only a certain number of eggs a chicken can produce, not decimals of them. All right, not fractions of eggs. They get whole eggs. That's all you get. It's the same with rolling a die. Rolling a die is countable. All right, it's finite. You get whole amounts in them. All right, so now time to blow your mind. If I roll a die that has sides labeled A 1.245C dog, is that discrete? That means every single side. This is on side 1, side 2, side 3, side 4, side 5, and side 6. Is it discrete? All right, so the question is, the answer I should say is, yeah, it is discrete. The reason why it's discrete is because I can get a finite number of A's, a finite number of 1.2s. I can count the number of 4s or the number of C's or the number of dogs. I can count them. All right. The sides may be labeled something weird, but the action of rolling the side A is countable and finite. So we're more focused on the action and not necessarily the number. The action of rolling 1.2 is countable and finite and whole. All right. This is another one of those trick questions that they'll try to get you on the AP exam. So that's why I need to make sure you're paying attention to it. There are 6 total options, and we can count the number of times each of them come up on your die. But then you have the other type, and the other type is a continuous data set, and it's infinite, and it's not countable. Okay? So it's infinite, goes on forever. So an example of continuous data are usually measurements of some kind. Okay? For example, how hot do you think it is outside? All right, let's say we went outside with a thermometer, all right, and will it be exactly what you thought it was? I go, yeah, it's 42 degrees. Are you sure it's 42 degrees? Probably not, all right? It might be 42.1 degrees. It might be 41.9 degrees. There's truly an unlimited number of possibilities that it could be. It might be 41.0014261. That's a possibility, all right? You could guess 85 degrees, right? Maybe it's 86, maybe it's 85.1, maybe it's 79, right? I doubt it, but it could be negative 16 degrees or 137 degrees, right? And in between each number, all right, there is an infinite number of possibilities. This starts diving into some calculus concepts, but the idea here is there's an infinite number of numbers between each number, between each decimal. There's an infinite number of numbers and decimals. Therefore, measurements are normally continuous data because there is an infinite number between infinite numbers. That's just how it works. But we cannot have an infinite number of eggs between eggs, right? I have 3 eggs, I have 4 eggs. I don't have an infinite number of eggs between there. I either got 3 eggs or 4 eggs, that's it. And the idea of being continuous is the same with temperature, right? It's the same with height, weight, income, all right? So, next up, 4 levels of measurement, all right? And this is a lot of terms. This is a lot of notes for you to be writing down, so I hope you guys are pausing these videos, writing down the notes as we go, right? Nominal data. Nominal means name, right? Name, nominal. See it right there? All right? These are like the categories, all right? This is data that can't be ordered like religion, race, or gender. Can't be ordered. All right? You cannot do mathematical operations on religion. You cannot do mathematical operations on gender or race. So, ordinal data. Ordinal means order. Okay? So keep this in mind again, going back. Nominal data is like names. All right? That's what we're talking about. And we're talking about the categorical types. So nominal is like the names, religious, race, gender, right, hair color, things like that. All right, ordinal means order. This is the data that can be ordered, but the difference of the data are meaningless. You can order them, but it doesn't matter if you take the difference of them. All right, a car race. Think about a car race. Perfect example of this, of ordinal data. Okay, 4 cars race and go around a track, right? Can the racers be ordered? The answer is yeah. We get first, second, third, fourth place, right? Sure. But does their place tell you anything other than the order? The place tells you nothing else. All right? Ordinal data, it won't say anything else. Now, I could try to find stuff from it, but it's not going to elaborate and tell me anything else. The time or measurement or distance between the cars is not important. It's just this guy could have won by literally 0.01 of a second, but he still won. That's not factored in. It's just a rank. When you look at it, you go, yep, there's the order. It's just the order. Another example, all right, is rank, all right, or even colors can be ordered in science, right? Colors are ordered by the spectrum. Interval data, all right, is another one, another type. Okay, so we just had nominal, we had ordinal, we have interval data. It can be ordered, and the differences are meaningful. So interval data, it can also be ordered and it can be meaningful. However, there is no natural zero in that data. Okay? If you have a bank account and you see a 0 in it, do you have any money in it? And the answer is no, don't have any money in it. If your thermometer reads 0, though, do you have a temperature? And the answer is yes. That does mean there is no temperature, right? Doesn't mean that, right? It literally means an absence of temperature. There is no temperature there. You can have a temperature of 0. Okay? Natural 0 means there is nothing there. Your bank account has nothing, right? That's natural. All right? Temperature is not a natural 0. Therefore, temperature is an example of interval data. All right? Because you count the 0, but it doesn't mean nothing. Basically, is what we're getting at. All right? When I come back here, I'll finish up with some more of the data types, but I don't want to try to race through just so you see it. But when we come back, we'll look at the ratio data type.